Greetings, algebrites. We are going to do three things on this lovely day. Number one is that we are going to look at categories of numbers, which include natural numbers, whole numbers, integers, rational numbers, irrational numbers, and we're going to introduce complex numbers. And we are also going to define and graph our imaginary numbers. And lastly, we are going to solve a few complex problems, or quadratics that have complex solutions. So the first things first. Let's look at natural numbers and to see where they fit on the number line. Natural numbers are simply numbers by which you've counted with historically throughout the ages. So things like 1, 2, 3, 4, etc. All of these are called natural numbers. In addition, folks discovered that 0 is a number as well, and so whole numbers are all the natural numbers plus 0. So whole looks like this. Whole would be all the natural plus 0, and that's the only difference. Next, we have integers. Now, integers would be any whole number and its negative. 0 does not have a negative. So all of these would be my integers. Rational numbers. Now, of course, if you look on your number line, if you look inside here, we can go from 1 to 2, but we can also go between 1 and 2. So this is what some people did. Hey, I can go between 1 and 2. So I can go halfway, I can go a quarter, I can go 1/8, I can go 1/12. So they would keep subdividing it like this. And usually we think of it in terms of fractions. And that's a great way to remember this. Rational numbers are numbers that are fractional numbers. So notice 2/3. Negative 1.4 can be written as a fraction, 4/10 here. Negative 9/2. So any number that can be written as a fraction, we can call rational numbers. So let's graph a few of these ones here. So 2/3 is going to be somewhere about here. And negative 1.4 is going to be here, almost halfway there, etc. So these are all, my friends, rational numbers. Now, sometimes we can't write numbers as fractions. So we have a whole nother category, and these ones are called irrational numbers. Irrational numbers. So numbers like pi, 3.141592654, phi, 2.618, etc., radical 5, the opposite of radical 17. So I'll just throw a few of these ones on. So pi lives right about here, and phi, 2.618, 1.618. Oh, hashtag. That would be horrible, embarrassing if I actually put that in. So that's right about there is phi. The square root of 5 is 2 point something or another. Square root of 5, etc. So those are all, my friends, irrational. But one thing we had said was that we cannot have the negative inside the radical. We said that was forbidden. That took us outside real numbers. Well, if this line represents real numbers, then all I need to do is go to another dimension. Go off the real numbers, and now I have something that is called imaginary numbers. Imaginary numbers. So that would be anything that has a square root of a negative number. So for example, the square root of negative 1 would simply be right here. The square root of negative 1, right there. And another number for that is I, and we'll define that in a minute, which means this is 2i and this one is 3i, etc. And so in order to graph, say, something like 3 minus 2i, all we need to do is go to 3 along the real numbers to here, and down 2i. So down 2i would be roughly here. So here's negative I. So here'd be negative 2i. So that means 3 negative 2i, or 3 minus 2i, would be right there. So that's our introduction. So let's officially define what imaginary numbers are. The square root of negative 1 we call I, because it goes off the real numbers, hence imaginary. Or another way to define it is that I squared is negative 1. Standard form is where we put our real number first and we add our imaginary component second. Notice that b is not 0 if this is a complex number. Pure imaginary is when a is 0, so a pure imaginary number would be anything on this line here, even the fractions or inside. Now let's take a moment to consider I squared and find a pattern of some kind. So I is defined as I, so there's nothing crazy there. And I squared we already defined as negative 1. Well, notice with I cubed, we can split that up into two things, I times I squared. So I just take I, put it there, I squared, and put it there to see what I get. Well, I stays there, negative 1 stays there. So what do I get? Negative I. So my result is I cubed simplifies to negative I. I to the 4th power can be broken up to be I squared times I squared, which is negative 1, times negative 1, which gives me positive 1. So I to the 4th power is simply 1. If we notice the pattern here, what we get is I to the 4th power times I, and we already know that I to the 4th power is 1, so that goes here. And I just get 1 times I, which is I, and it loops me back to this pattern here. So just to follow the pattern here, I get negative I here and positive 1 here. So notice that there are 4 terms in my pattern: I, negative 1, negative I, and 1. So how does that apply to something? Well, let's say we have something a little bit more complicated, I to the 9th power. So what we can do here is take our 9 and divide it by 4, because there are 4 terms in the sequence. And in the end, so just like we did in 3rd and 4th grade, we end up getting 2 remainder 1. So here's the key. It's the remainder that's important. So now, it turns out that I to the 9th is exactly the same as I to the 1 because of the 4-term pattern. So I to the 1 is simply I, according to my chart here. So I'm done there. So let's look at this problem here. We're going to bring down this negative after we evaluate things, but I'm going to divide this by 4 to get 3 remainder 0. And so therefore, I to the 0, and if we recall anything to the 0 power, a to the 0 power is 1, which is equivalent effectively to I to the 4th power. So I bring down this negative, and I bring down this 1, and there's my answer, negative 1. The next two things we're going to look at is graphing, or interpreting the graph of complex numbers, and lastly, solving equations with complex numbers. So if we look here, let's take a gander first at number 6 here. This is the real number line. So we have 1, 2, 3, 4, etc. This is the imaginary number, 1i, 2i, 3i. So it might be easier for us to look at it in terms of i's and not simply the coefficient. So if we consider what this one is right here, that's simply 1i, 2i, 3i, 4i. So this one here is 4i. Well, just like on a coordinate plane, where we have an x and a y, that's the same thing here. I have a real number right here, so I go 1, 2, 3. So for C, it's going to be 3, and going down here, negative 1i, negative 2i, negative 3i, etc. Well, this one's at negative 1i. There we go. So my final result is simply 3 minus I. And B would be this, negative 1, negative 2, negative 3. Negative 1i, negative 2i, negative 3i. So negative 3 minus 3i is the result there. Now take a moment to practice 5 and 7. Last thing here is that we're going to solve the equation. I'm going to look at a simple one and then one a little bit more complex. So first things first is I need to isolate my square so that I can take the square root of both sides. The first way to do that is to subtract 49 from both sides, bring down the x squared to get negative 49. Now when I take the square root here and the square root here, don't forget your plus or minus. I get x equals plus or minus, and now I need to simplify this right here. The negative comes out as an I because the square root of negative 1 is I. And the 49, if we need to see how that breaks up, some people need to use a factor tree, and any repeats come out. Notice the 7 repeats. In other words, 49 is a perfect square. So my answer is plus or minus 7i. Now let's look at example number, letter B, excuse me. We're going to follow the same procedure. I'm going to isolate my square by taking care of my constant first. And then I am going to divide both sides by 2 and get x minus 2 quantity squared equals negative 16. And now I can take the square root of both sides. Again, do not forget your plus or minus. So here I get x minus 2 only, and now I can simplify this to be plus or minus 4i. Again, where does that come from? Radical negative 16 is the same thing as saying radical negative 1 and radical 16. So this one here converts to I. The square root of 16 is 4, and so now we just put that in standard form. Now I'm going to add 2 to both sides, and since these two here are not like terms, this doesn't have an I just write what I see. So x is going to be 2 plus or minus 4i, and there's my answer. Now you can take a moment to practice these 12 problems. The answers are posted on my website.